Existing generation capacity depends on fossil fuel power plants. Steam, gas turbine and combined cycle power plants are the main types of power plants. Diesel-type power plants are available but in smaller scale. In combined cycle power stations, there is an assembly of heat engines, gas turbines, and steam turbines. In gas turbine, fresh atmospheric air flows through a compressor that brings it to higher pressure. Heat is then added by spraying fuel into the air and igniting it so the combustion generates a high-temperature flow. This high-temperature high-pressure gas enters a turbine, where it expands down to the exhaust pressure, producing a shaft work output in the process. The turbine shaft work is used to drive the compressor and the electric generator that are coupled to the shaft. A heat recovery steam generator captures the exhaust heat from the gas turbine that would otherwise escape through the exhaust stack, and creates steam which spins steam turbine. Therefore, both gas and steam turbines work from the same source of heat, converting it into mechanical energy, which in turn drives electrical generators. The flow of electrical power is from power plants to switching stations. The generated power may have voltage level of 13.8, 20 or 24 kV. Now we finished from the part of how SEC produces electricity. Let's see how it transmits this current and how it is distributed to customers. Its switching station. Step-up transformers are located to raise the voltage to transmission levels. This step is essential to minimize the transmission losses and get economical cost for power transmission. Power transmission is an important section from the electrical power system. It transfers the generated electricity from the power plants to the main supply points, biasing transmission lines, which are the connecting links between the generating stations and the distribution systems. The transmission network consists of transmission lines with voltage levels of 380 kV, 230 kV, 115 kV, and 69 kV. The 380 kV is provided if the electrical power is necessary to be transmitted to far cities, whereas the 230 kV is used for power transmission in near cities. Switching stations are such as bulk supply points, BSP, and grid stations. 380 kV or 230 kV transmission voltage levels are mostly exist in bulk supply points, which are located at the boundary of the city. The grid station receives 115 kV or 69 kV electrical energy through cables and steps it down to 13.8 kV. Grid stations, which are located inside cities, are considered as the final link in the transmission network. For higher consumption level consumers as factories and trading centers, the supplied power may be with high voltage levels as 69 kV or 13.8 kV, through a specific substations with a required and a suitable power size. Residential customers are supplied from the distribution network substations. The substation has a transformer which converts the 13.8 kV to low voltages of 127 volt or 220 volt. The low voltage is distributed from the low voltage panel. Finally, the low voltage is delivered to the customer by using a mini pillar, so customers receive a supply of electrical power required by them at the time and place at which they can use it.